Tables. Tables are tabular presentations of information. So a table means that we could have information that is presented in a couple of different ways, but it's always in what we call a tabular form. A table, by definition from dictionary.com, says it's an arrangement of words, numbers, or signs, or combinations of them, as in parallel columns, to exhibit a set of factors or relations in a definite, compact, and comprehensive form, a synopsis or scheme. And basically what that is saying is that when you have a table, you will have different columns and different rows, and this will present data in a way that you can observe it. One of the interesting things about tables is it gives you an ability to do things exactly. If you've got a graphic representation of data, you put a number out, but you can't tell how many decimal points or anything like that that particular number has. When you have a table, you can put down the exact number of significant figures that you're looking at. When we deal with tables, a table should have a header that is self-explanatory. The table should be able to stand alone, so if someone reads the table, they should be able to understand what was done. A table should have an explanation that is sufficient so someone can read it and understand what was done to get the data that was there. Tables just should not have a one-word opening statement. There should be something there. Now, that doesn't say that all tables have that, but that is really what you would want to be there. When we look at tables, the heading of the table goes above the table, and the first line of that heading would go into the list of tables in your table of contents. So we're looking at it being on top and going from there. Now, I've got a couple of examples here. This is one where the top of it doesn't tell you anything. These are host species of grasses that have been reported to be infected by pericularia, and it shows the different species of pericularia. It also shows you the nidial dimensions, which is a very interesting thing, and it also gives you the reference in it. So when you're looking at this, it gives you a lot of information out here, and basically this is a listing of plant species that have been reported to be infected by pericularia. You can see that we've got up into B on this, which meant that this table was approximately 10 times the size. This is a table out of the American Eurasian Journal of Agriculture and Environmental Science, and it says Table 1. Slopes of regression lines of the number of culms formed by Imparatus cylindrica, switchgrass, maiden cane, and muhly grass plants. The number of culms were counted every 2 days during the study, and the data for both years were pooled. N equals 132. Slopes within plant species followed by similar letters are not significantly different at P equals 0.01. So when we look at it, we start out and it shows you a slope of something like Kogan grass periods. We know that our time period in here is every 2 weeks, and we're looking at this over a growing period. There should have been representatives in here. It's down at the bottom. It says Kogan grass, switchgrass, maiden cane, muhly grass. The presence of more than one letter indicates a combination of plant species in each treatment. The R-squared value gives an indication of goodness of fit. At A equals 0.05 and N equals 132. An R-squared value of above 0.03 would indicate a good fit for the data. And then 22 refers to the paper that said that. So anything in here that is above 0.03 would be a good fit. And what you can look at is in here you can see the CS midway down. It gives you a value. It says that value, which is your slope, is different from the one where it was just Kogan grass on its own, and it shows you what your R-squared is. And if you continue over, it also gives you that for switchgrass because CS has both Kogan grass and switchgrass, and you can see that also has a good fit. So in here, it's basically giving you information about goodness of fit. One of the things you look at is in Kogan grass, you get a lot of differences based on competition from other grasses, where in something like muhly grass, it doesn't change. Again, this is tabular data where you could go back and you could take the information from it and use the information as you see fit, and it would allow you to do that. If you put these on a more visual form, you might not be able to get out the same data that you have in here. This is where a table comes in very good. So when we're looking at this, we can see up at the top, you have your table number, you have your header, which is up on the upper part up here, and down on the bottom, you have got a legend which explains what's going on in here if there are things that need to be explained. So you've got a table here that fits together, gives you a lot of information, gives you a lot of things that you can actually get information out of, and therefore it comes out as a good sort of table. So when we look at a table is a very good sort of representation for us to be able to understand information and get access to it very quickly.